In this video, we will discuss how to get different devices to work with our smart home. The idea is to understand how the device under test actually communicates and how to mock it. Today we will look at this Energenie kit. I bought this kit several years ago and it comes with a remote and 4 outlet points. The remote has 4 on-off buttons for each outlet and a final one to switch all of them on or off. Well, how does it work? Looking at the remote, we don't see any protruding IR LEDs like a traditional remote. Also, we know that the remote doesn't require a line of sight. That limits the technology it can be using. As it doesn't depend on Wi-Fi, the only remaining options are either radio technology or Bluetooth. And if we look at the back of this remote, we see it mentioning 433 MHz frequency. So this is obviously using RF. The first thing you would want to do is to identify the method the device is using. If it's using an app, it's super easy to know as it would require either Wi-Fi or Bluetooth enabled. For devices with hub and remote, well, if the remote requires line of sight, then it's most probably using infrared. With a hub, well, it's a bit harder to determine. In that case, your easiest option is to search on the internet. Second step is to figure out what exactly is happening during the events. As in, when I'm pressing the button on my remote or on my app, how's the device being turned on or off? We know what technology it's using, so now we need to know the exact syntax. In computing, we call this sniffing. Now, most companies do not publish these communication details. So your option is either to search on internet to see if anyone already has documented this device communications. If not, you'll just need to do it yourself. This process can be difficult at times, but for our example today, it's rather simple. There are some prerequisites though. You will need a 433 MHz FM receiver and a transmitter, a Raspberry Pi, Arduino or any such devices that can communicate with said receiver and transmitter. On screen you are seeing my setup using a Pi. With that in place, I will log into my Pi to run the sniffer. With the sniffer running, when we press a button on the remote, we should see a code coming through. We'll see a decimal value, but obviously that value would represent the correct binary format required. I'm noting what code is being displayed for each button. At times, I might get multiple lines for a single button press, but that is just imperfection with the remote button, and I can ignore any duplications. For the all on or off button, we see it sending out 2 different codes, just like the rest. But I don't really care about the master button, as it wouldn't be really useful in my smart home automation. So part 2 is done. You know exactly what is being said between your device and controller. Final step is to mock it, i.e., programmatically send that code using your smart home system. In current case, this outlet is listening to RF signal, so we just need a transmitter and then use it to send the correct code. Back in my Pi, if I run the command code send 8782915, where that decimal value is what I got when pressing on for outlet 4. If everything is connected properly, this should now switch on the outlet. Great! Now to run the command to switch it off. Beautiful. Finally, I have written a simple service that simply sits there and waits for my signal, upon which it transmits the appropriate RF code. Note, these outlets don't broadcast their current status, so there is no way to know if a particular outlet is currently on or off. If you need to, you will have to track it yourself. There are a couple of things I would like to gloss over. I don't see any point of breaking down on how RF code is actually working. In a nutshell, most of them are using ask method, which stands for amplitude shift keying. Simply put, normally nothing is being transmitted from this remote, so that's a null value. When sending actual data, this method distinguishes 1 and 0 using pulse length and interval, where 1 is a short on followed by a long off, where 0 is a long on followed by a short off. Please understand that we are talking about lengths that are super small and normally specified in microseconds. If your outlet uses a non-standard length, you might be able to receive the code, but transmitting it wouldn't change this outlet status. In that case, you might want to try different pulse length and see if that works. My final remote code is not on GitHub right now, but it is super simple. If there is any request in the comments, I will upload it and link it in the description. Have fun with your home automation.